In this video, you will learn to graph circles and inverses. First, we will concentrate on graphing circles. X squared plus y squared equals r squared is the equation for a circle with the center at the origin and a radius of r. You will need to solve for y so you can graph the top half and the bottom half of the circle. The top half will be y equals the square root of r squared minus x squared. And the bottom half will be y equals the opposite of the square root of r squared minus x squared. So let's take a look at example number 1. We want to graph x squared plus y squared equals 16. This means that r squared is equal to 16, so r will equal 4, with the center of the circle at 0, 0. Solving for y, we get y equals plus or minus the square root of 16 minus x squared. So you will need to graph y equals the square root of 16 minus x squared, and y equals the opposite of the square root of 16 minus x squared. So let's do that. We're going to go into the graphing mode, so we hit y equals, and we're going to put in the top half of the circle. So that is the square root, so we hit second function, square root, and then 16 minus x squared. And then we close the radicand here. Okay, so this will be the top half of the circle. Now let's go down to the second line here, and let's input the bottom half of the circle, and that is the opposite of the square root, so second function square root, and we're just basically going to type in the same thing, 16 minus x squared, and then we close the radicand. So let's go ahead and hit the graph button to see what this looks like. Notice the circle looks like an ellipse. This is because the x-axis increments are slightly larger than the y-axis increments. So you can see here the spaces between each increment are a little larger here than they are here on the y-axis. To fix this, go to the zoom mode and select z square. So let's go to zoom. And right here you can see number 5 is z square. So if we just hit number 5, now it looks more like a circle rather than the ellipse that we saw previously. So whenever graphing a circle, use the z squared mode. And remember, to get there you go zoom and then you hit number 5 for z square. Just take a quick look back. If we go to zoom and in the standard mode, number 6, this circle gets elongated and looks like an ellipse because, like I said, the increments are a little bit more on the x-axis than the increments on the y-axis. So go back to zoom and hit number 5 for z square. And there we have it. Now we will use another method to graph the circle by using the built-in function called circle in the draw mode. So what I'm going to do first is I'm going to go ahead and clear this function out to get rid of this. So we hit y equals, and then I'm going to clear out the top of the circle and the bottom of the circle. So hit clear and then move it down and then hit clear again. And then we can get out of this by hitting second function and quit. So let's go to the draw mode. So we hit second function, and then you can see here is draw. So we'll hit that key, the program key. And we want to scroll down until we see the built-in function that says circle. So we don't see it here on the screen, so let's keep moving down. Number 9 says circle. So if we hit enter, we have on the screen circle with a left-hand parenthesis. So the notation for the circle, as you can see here on the right, says circle H, K, R with the center at HK and a radius of R. So if the center is at the origin, the notation would be you'd have circle and then you'd have 0, 0, and then whatever the radius is. And then you close the parenthesis. So in our first example, we know that the center was at 0, 0, so we would go ahead and put in 0, 0, and then comma, and we want to put in the radius, and remember that the radius was 4. So we put in 4, and then we close the parenthesis. So this is the notation for any type of circle. You put in the coordinates of the center and then the radius. And this is, of course, the x value, the y value, and then the radius. So now we simply press enter, and it graphs the circle. Now, since we're already in the z-square mode, remember, let's hit the zoom button. Number 5 is z-square. Let's quit out of this, and we'll hit enter again. It's automatically going to graph the circle in the z-square mode, and it looks like a circle instead of an ellipse. If we were in the z-standard mode, number 6, it would look like an ellipse. So let's quit out of this and hit enter to go back. Recall to the right is what the graph looked like when graphing the function for the upper half of the circle and then the function for the lower half of the circle. And really the only difference you can see on the screen is that there's a slight little space here and here on the other graph. And that's just what happens when you graph each part of the circle separately. Okay? So as you can see, using the built-in circle function in the draw mode is an easy and fast way to graph a circle as compared to inputting the functions for the lower and upper half of the circle. Now, the circle is stored into memory and will always be seen in the graph mode unless you clear it out of memory. So what I'm talking about, if we went in and select y equals, let's just graph a simple line, so we'll put in y equals x, and then if we hit graph, see, we not only see the line, but we still see the circle. So what we need to do is we need to get rid of this circle in the memory of the calculator. So how we do that is we go back into the draw, so we go second function, and then here's the draw, so you hit the program button, and the first line says CLR DRAW, means clear the drawing. So if I just hit number 1, you can see now that it cleared the drawing of the circle and it kept in the function y equal x on the graphing screen. So let's go ahead and move to example number 2. But first let me clear this out. So we hit y equal, and let's clear this. And let's get out of this, second function, quit. And we will hit clear to get rid of the circle there. So example number 2, what we're going to do is we're going to graph the quantity x minus 2 squared plus the quantity y plus 4 squared equals 25. So in this case, r squared is equal to 25, so r is equal to 5, with the center of the circle at 2, -4. Now solving for y, you end up with the equation y equals -4 plus or minus the square root of 25 subtract the quantity x minus 2 squared. So you need to graph y equals -4 plus the square root of 25 minus the quantity x minus 2 squared, which is the top half of the circle, and y equals negative 4 minus the square root of 25 minus the quantity x minus 2 squared, which is the bottom half of the circle. Now, once again, we're already in the z-square mode, so let's keep it there because we're going to graph a circle and we don't want it to look like an ellipse. Alright? So let's go ahead and input the top half of the circle first. So we hit y equals, and now we input negative 4 plus the square root of 25 subtract the quantity x minus 2 squared, and then we're going to close the radicand. So that's the top half of the circle. Now let's graph the bottom half of the circle. So that's going to be negative 4 minus the square root of 25 subtract the quantity of x minus 2, close the quantity and square that, and then we're going to close the radicand. So we have the upper part of the circle and the lower part of the circle, and we're going to hit graph. What we have here is the circle, which is centered at 2, negative 4. So you can see if we go over 2 and then down 4, we're about right there, which is the center. Now again, notice these little gaps here, and that's just the way that the calculator operates when graphing the upper part of the circle and the lower part of the circle. We won't get really into the details of the y's, but that's just how it does it. So remember now, we also have an alternative method of graphing this circle, and it's very simple. And remember, we can use the built-in function called circle in the draw mode. Let's go ahead and clear the two functions out of here. So let's clear this out, hitting clear, and let's clear that. Okay, and let's get back to the main screen here. So remember, to use the built-in function, we're going to the draw mode. So we go second function, and then here's the draw, so press program, and we need to find the one that says circle, and there it is. So we hit enter. Okay, and remember the notation. We're going to put the coordinates of the center, which is at 2, comma, and then negative 4, and then one more comma, and we're going to put the radius in, and the radius is 5. So we hit 5, we close the bracket there, and so now here's the notation for our circle, and we simply hit enter to graph it. Now here it graphs it really nice. It does a complete continuous circle here where there's no gaps like we had before, and you can see to the right is the screen capture of what the circle looked like previously when we graphed the upper half and lower half. So this is a very nice option in the calculator to use the draw mode and use the circle function. Okay, so again, since we're already in the z-square mode, it looks like a circle, but if it was in the z-standard mode, it would look like an ellipse. And let's just verify that. If we go to zoom and then we go to z-standard, we hit number 6, and now we go ahead and let's quit out of this, quit, and then we're back to our circle function that we just inputted, and if we hit enter, now it should look like an ellipse, and it does. Now, if you use the circle function to graph the circle mode while you are in the z-standard mode, which we are, okay, you will need to use the following steps to set the mode to z-square. And I just did that. If you didn't really pay attention, this is what I did. I have to go back to the zoom, and I'm going to select the z-square. So that's number 5. All right. So what this does is it just shows you the z-square window, what it looks like. Okay, and you can see here that the increments look the same on the x-axis and y-axis. So let's get out of this screen by selecting second function and then quit. And that takes you back to our circle function that we inputted just a little while ago. And then we go ahead and we hit enter, and now it's going to graph it in the z-square mode. So it's very simple. That's how you go back to the z-standard mode or z-square mode to view your graph, depending on which mode you're in. So now we will learn how to graph inverses. So let's clear this out. So how do we get rid of this? So what we need to do to get it out of memory, remember that we need to go to second function and then draw. And then the first option says clear the drawing. So that's number 1. So we hit number 1 and then it gets rid of it. Alright, so let's go second function and quit. And we can clear this out by simply hitting clear. So for example number 3, let's say we wanted to graph the inverse of y equals x cubed plus 1. First you would go through the algebraic manipulations to solve for the inverse, which gives you y equals the cube root of x minus 1. So let's put in the original function first. I said that was x cubed, so here's the power, and then 3, so that's x cubed plus 1. Alright? Now I'm going to go down to the next line and I'm going to input the inverse function. And remember we just said that was the cube root of x minus 1. So we need to use a key that we haven't used in a while, and that's the math key. So if we hit math, there's the cube root right there. It's a built-in one. So we can hit number 4. And we're simply going to put in x subtract 1, and then we're going to close the radicand. Okay? So we have the original function, and then this is the inverse of that function there. Now, if we go ahead and hit graph, this is what we get. So it first draws the cubic function, and then it draws the inverse. Now when we graph the original function and its inverse, you will notice there is symmetry. So you can see kind of some symmetry here that goes on. It looks kind of symmetric. But what's it symmetric about? Well, the symmetry occurs about the line y equals x. So we can graph the line y equals x to illustrate this. So if I graph y equals x, that should be a line that goes right through the origin, and it splits itself between quadrant 1 and quadrant 3. So let's do that. So that's y equals x. And let's graph that. And there it is. Now you can see the symmetry a little bit better when you take a look at this line, how it splits it up. In fact, any point along this line, there's an equal distance from curve to curve. So from here to here is the same from here to here. Alright, so just as there was an easy way to graph a circle, there is an easy way to graph an inverse. So let's clear the inverse function and the line of symmetry to show another way to graph the inverse functions. So if we press y equals, let's go ahead and clear the inverse function and the line of symmetry right there. And if I hit graph, here we just have our simple cubic function. Okay? So remember, like we did before, we went to the draw mode to get the circle function. We're going to do the same thing to get the built-in inverse function. So we go to second function and then draw, which is right here. So we hit the program button. And then we're going to scroll down and we're going to look for something that says draw inverse. And there it is. It's right above the circle function. So number 8 says draw inverse. If we go ahead and hit number 8, all right, there it says draw INV. So what we're going to do now is we're actually going to put in what we want to draw the inverse of. Well, we want to draw the inverse of x cubed plus 1. So if we hit enter, there it is. So it kept our original function, which we had under the y equal to. There's our original function. Let's quit out of this. And then what this does is it draws the inverse of that original function that we have stored in the graph mode. So we hit enter, and there it is. This curve right there, which looks exactly like our original graph of the inverse function. And that can be seen just to the right here. Let's go back to the draw mode. So second function and then draw. And we're going to clear that inverse function. So we hit number 1. So is all that it's going to show is the graph of what we have in the graphing mode, which is right here. All right? And let's go ahead and clear that function out. If we hit clear. Okay, and then we'll go second function and quit. And then we can go ahead and clear this out by hitting clear. Alright. Just an important note. The built-in functions to draw a circle or an inverse are very convenient, fast, and easy to use. However, you should know how to do the algebraic manipulations in order to graph circles or inverses, either by hand or manually inputting them into the calculator. This concludes the video on graphing special functions, specifically circles and inverses.